Welcome to another episode of MrLopezClasses.com. We are going to continue in our book of corrosion, and this is the chapter 1, and this is the second episode of the chapter 1. In this episode, we are going to continue with the ionization and the anode and the cathode, very important, chemical bonding, ionic, covalent, that I explained a little in the previous episode. Okay, we are going to finish with the chapter 1 of our book of corrosion. Don't forget, we are going to follow the textbook, and we are going to follow also the ABYC study guide, the ABYC corrosion study guide, both of them. Okay, ready? We are going to start with the flow of electricity in the boat. Why the electrons move in between metals in the conductors? Why the electrons are moving? Excitation is the process where the electron in an atom gains energy, and because the high energy, it cannot reside in a particular orbit and try to jump it into other orbits. In other words, if I have an atom and I added energy, for example heat, the outer electrons, the electrons of the last orbit, try to jump it to other atom. Yeah, it's clear? If I added energy, if I excited the atom, the outer electrons in the last orbit jump it to another atom. The most common way for electrons to move to an excited state is by absorption of electromagnetic radiation. This is a nice sentence. The most common way for electrons moving in other state is by absorption of electromagnetic radiation. Nice slide, important slide. Okay, we are going to check what happened in that case. According with this, we are going to check what is the definition of a photon. What is the meaning of a photon? A photon is produced whenever an electron in a higher than a normal orbit falls back into the normal orbit. Once again, a photon is produced whenever an electron in a higher than the normal orbit falls back into the original orbit. It's the return of the electron to the original orbit when the atom lose energy, lose heat. The electron tries to return to the original orbit. During the fall from the high energy to the normal energy, the electron emits a photon. The electrons emit a radiation. The electrons emit a beam of light. That radiation is a packet of energy with some specific characteristics. Once again, we are going to check the definition of a photon. Is the energy released by an atom when an electron that is excited, the electron jumped in a higher orbit or into another atom. When that electron tries to return to the previous orbit, emit a package of energy, emit a photon. This is the definition of photon. It's simple. The photon has a frequency or color. That color depends on the distance that the electron travels in the process of return. You can see this phenomenon in the lamps, in the neon lamps, in the fluorescent lamps, because inside of those fluorescent lights you have neon and sodium and vapor. Those lamps, they work with the principle of the photons. In other words, those lamps, the neon lamps, are lamps that collect different amounts of radiations, photons. Yeah, for that reason you founded those neon lamps in different variety of colors. There are neon lamps with a yellow light, with white light. Is depending of the intensity of the photons is the color of those lights. This is a photon. Is the energy released for an atom when an electron excited try to return to the original orbit. Simple, right? This is good. We are going to use later that definition. And now we are going to talk about ionization. What is the meaning of ionization? And we are going to check different examples. When energy is added to an atom by some exterior force, for example heat, friction, or if you inject a flow of electrons, the atom right now is excited. Ionization is the excitation of the atom. Simple. Okay, ions. We are going to check the ions. Each time that you combine an atom with other atom, you produce compounds or molecules. You remember that? In that procedure, one atom releases electrons and the other atom absorbs electrons. You remember? The atom with more energy absorbs electrons, absorb negative charge, and the element with low energy, with low electronegativity, release electrons. Pay attention. What is the charge of the electrons? Negative. What happens if I have in this pocket a lot of electrons? I put a lot of electrons here. What is the charge of this packet? Positive or negative? I have 2 millions of electrons. The charge of this element is negative because the charge of the electrons is negative. What happens if I have 1 million of electrons? I am going to remove 100,000 electrons. 100,000 electrons. What happened with the charge of this package? Is more negative or more positive? Is more positive because release a lot of electrons. Each time that an element release electrons, that element become a little more positive because release negative charge. The other element, the element that receives negative charge, at the end of the day is more negative. Okay. What is the ion of the element that release the electrons? The ion of that element is positive because release electrons. And what about the ion of the element that receive electrons? The ion of that element is negative because absorb more negative elements is more negative. That's important. Let me check. If a neutral atom gains electrons, become negative. If a neutral atom loses electrons, become positive. This is nice. We are going to analyze, for example, the previous example about the salt. You remember what is the formula for salt? Is sodium and chlorine. You remember that sodium releases 1 electron and the chlorine absorbs that electron. At the end of the day, what happened with the charge of the chlorine? The chlorine absorbs more electrons. The charge will be more negative. The ion of the chlorine is negative. And what about the ion of the sodium? The ion of the sodium is positive. The element that releases electron at the end of the day is positive, and this is the anode. And the element that receives electrons at the end of the day is negative. This is the cathode. Wonderful. This is nice, no? This is exactly the example of the battery in your car. In the battery of your car, you have two terminals of lead into the electrolyte. You remember the procedure to create a cell? I explained in the chapter 3 of your book of marine electricity. I explained the procedure to create a cell. If you have a plastic container and you introduce electrolyte, you remember what is the meaning of electrolyte? It's the combination of water and acid. The most common electrolyte is water plus sulfuric acid. 65% of water, 35% of acid. This is a good electrolyte. This is a good conductor of electricity, electrolyte. Okay, if I have that container and I introduce two pieces of lead, immediately you introduce the two pieces of lead, one piece of lead becomes positive and the other one negative. Which one? I don't know. And why? Ask to him. Because yes, I don't know. The element that becomes positive is the element that is releasing electrons slowly. And the other terminal that is right now negative is the element that absorb electrons. The element that at the end of the day is charged full of electrons is the cathode. And the element that, the terminal that at the end of the day release a lot of electrons is the positive terminal. You remember what happened in the battery of your car with the positive terminal after 1 year of operation? The positive terminal is completely eroded. Because each time that the positive terminal releases one electron, is produced one hole, is eroded. That element that is eroded is the sacrificial anode. This is the element, this is the donor. This is the donor of electrons. And this is the receiver. The receiver. This is the sacrificial anode. Sacrificial. This is the element that donates electrons, release electron, is the anode, the sacrificial anode. Remember, I am talking about the flow of electrons. The current flow in the opposite direction. Don't forget that. I am talking in this moment exclusive about the flow of electrons. Okay, in a battery, when you have a battery, I'm going to do an example about the anode and the cathode. Suppose that this is the container, and I am going to locate the cathode here. Is with negative charge, and I am going to locate the anode over there, is the positive. And I have the electrolyte here, this is the electrolyte, the liquid, the conductor. Okay, how is the flow of electrons? The flow of electrons is in this direction. Look, the electron goes out from the positive terminal. The electron have negative charge and enter into the negative terminal. Each time that the positive terminal release one electron, one hole is produced. Yes, this is the positive terminal or anode. And this one, the other one, is the negative terminal. The flow of electrons is from the positive terminal into the negative terminal. And the flow of current is in the opposite direction. You remember I explained in the course of electricity. I explained that this is basically the same like the third law of Newton. when you apply a force to an object, the object produces an opposite force in the opposite direction. Equal force but in opposite direction. This is the third law of Newton, and it's exactly the same for this situation. The electrons flow from the positive terminal into the negative terminals, and the current flow from the negative terminal into the positive. It's the opposite way. Okay, my friends, and this is the concept of the ions, the ionization. We are going to refresh quickly. Ions are formed when atoms or group of atoms lose or gains electrons, lose or gains charge. Normally, the metal lose the electrons when they are combined with the oxygen. You remember in the periodic table? In the periodic table we have the oxygen in the group number 6 with high energy. And the majority of the metals are located here in this side. The majority of the metals are located in the transition metals, in the center, in the group of the transition metals. For example, when you combine iron with oxygen, what is the molecule for iron and oxygen? Is F2O3. It's 3 atoms of oxygen per 2 atoms of iron. This is the molecule of iron oxide. Okay, what is the element in, what is the positive ion and the negative ion in this particular case? What is the element in that molecule that absorbs electrons? The oxygen, because oxygen has more energy. It's in that corner. Okay, oxygen is the negative ion. Oxygen is 3 negatives. And what about iron? Iron is 2 positives. Iron is the positive ion, and oxygen is the negative ion. In the molecule of oxide of zinc, you remember? What is the positive ion? The positive ion is the zinc, and what is the negative ion? Is the oxygen, because the oxygen attracts the electrons of the zinc. What is the cathode? The cathode is the oxygen, and the anode is the zinc. The zinc is eroded. For that reason, when the oxygen attacks the zinc, at the end of 1 week, you have white powder over the zinc, because the oxygen produces that oxide. That oxide is powder. And we are going to talk later what happened with that powder. Okay, the same with the iron. When the oxygen attacks the iron, in 1 week you have brown powder over the iron. This is oxide of iron. Good? You like it? Okay. According to our previous classes, I explained that the metals have excellent abilities, excellent properties. The metals in general are excellent conductors of electricity. All the metals. For example, iron. Iron is located in the transition metals. Iron works with 3 electrons in the last orbit. Iron is an excellent conductor of electricity. All the metals are good conductors of electricity. Aluminum is good conductor of electricity. Depending of the structure, some metals are better conductors than other ones. I'm going to explain later what is the meaning of that. But in general, the metals are good conductors. However, when the oxygen attacks the metal and produces that powder is a perfect isolator. When the oxygen attacks the metal, produces the powder. That powder is oxide of metal. The oxide of the metal is perfect isolator. For that reason, in the terminal of the battery, when the positive terminal is fully corroded, is covered with oxide of lead and oxide of copper, because normally the cable, the terminal is in copper. Those oxides isolate the contact in between the cable and the terminal. For that reason, in the battery of your car, you need each year remove the terminals and remove those oxides and put the metal in contact metal with metal, because those oxides are perfect isolators and isolate the flow of electricity. Yes, my friends, the oxides of the metals are perfect isolators. Those oxides of those metals, those powders, are used to create ceramics. Those powders, the powder of iron, oxide of zinc, oxide of copper, with glue create ceramics. And the ceramics are the best isolators. Incredible. The oxide of the metal is a perfect isolator. However, the metal, the pure metal, is a perfect conductor. Right? Don't forget, this is very important. And those are the ions. Those are the ions. I want that you check in your book, because I make a mistake. I apologize. I want that you do the correction. Right? Was my fault. I apologize. I need that you change, because in your book you have a opposite. The anode, the positive, is the electrode that releases the electrons when a flow of electricity passes through it. Is anode, and the charge is positive. And the second one is the cathode. Please verify your book and change that name. The cathode, negative, is the electrode that receives the electrons when the flow of electricity passes through it. Alright, please make the correction. I apologize. The second one, the anode, is the terminal where the currents flow in. Yeah, because the current flow in the opposite direction. And the cathode is the element where the current flows out, of course. And this slide is better. This slide is excellent, because look at this. The current goes from the negative terminal into the positive terminal. However, the flow of electrons is moving from the positive terminal into the negative terminal. Simple. That's clear? Don't forget that. The charge are moving from the positive terminal into the negative terminal. Each time that one electron goes out, produce a hole, and that element is more positive, and more positive. And the other terminal absorb electrons, is at the end of the day charged completely of electrons, and this is the cathode. The anode releases electrons and is eroded, and the cathode absorbs electrons and is more negative at the end of the day, is the cathode. However, the electricity flows in the opposite direction, from the cathode to the anode. Simple. Yeah, that's it. That's the definition. You don't need more. For example, in this particular scenario, the combination of zinc and aluminum. Let me explain something before we continue. We need to take care about this. There are metals that are not recommended be together in a marine environment. In other words, never put together aluminum and copper, because the most noble element attack the less noble, and at the end of the day the less noble is eroded. What is the meaning of more noble? Is the element with more electronegativity attack the element with less electronegativity. Let me check what is the electronegativity of copper. Copper is 1.9 millivolts and aluminum 1.5. Who is more noble? Copper. Copper 1.9, aluminum 1.5. Okay, and now we are going to return in our example. Copper and aluminum. Aluminum is if you have together copper and aluminum, copper is more noble, 1.9 volts, and aluminum 1.5. What element attack the other one? Copper attack the aluminum, and the aluminum at the end of the day is eroded. Alright, don't forget that. For that reason, never use aluminum with the copper together. For example, in the aluminum tank, when you use copper fittings, the copper fitting attacked the aluminum and eroded the aluminum around the fitting, and in 6 months, 1 year, you have a leak over there. This is catastrophic in a boat. For example, if this is the fuel tank, and one day in that area, in that boundary, there are too much holes, you have leaks, and you have a problem, probably you have fire in the boat. Be careful with that. Never put together copper and aluminum, especially because the structures are too dissimilar, and the most noble, in this case copper, attack the aluminum. Other example is with the aluminum and zinc. In this particular case, aluminum is more noble, it's in the right side of the periodic table, and zinc is a little less noble. For that reason, zinc is the anode, and aluminum is the cathode. Yeah, for that reason, you can protect lower units with the pieces of zinc. Lower units in aluminum with pieces of zinc. Okay, the zinc will be eroded, the oxygen in the water attack the zinc, and the zinc protect the aluminum. Okay, this is another great example. This is another good example in between two dissimilar metals, the outboards. In the outboard, we have the structure of the outboard in aluminum, and we have a lot of balls in stainless steel. Two dissimilar metals. It's a ferrous alloy, the stainless steel, in combination with aluminum, the aluminum of the block and the body, the structure of the outboard. If your outboard is not protected with sacrificial anodes, zinc in that case, the aluminum will be the anode and the stainless steel will be the cathode. In that case, the aluminum will be corroded because of the oxygen in the seawater. And the oxygen in the seawater is the electrolyte, and you produce a galvanic cell. And the more noble metal attack the less noble, and in this case, the less noble, the aluminum, will be corroded and eroded. Yeah, for that reason you need protect with the zincs. The zincs absorb the zinc, the oxygen attack the zinc, and the aluminum will be protected. The sacrificial anodes are mandatory, my friend. This is the only way to protect other metal is with sacrificial anodes. What is the best of the sacrificial anodes? Is the zinc. Magnesium also is good, especially in fresh water. And some aluminum alloys, we are going to talk later about that, are good in some specific situations, especially in brick water. Okay, my friends. Yeah, this is the example of aluminum and copper. You remember I explained in the previous one, aluminum is 1.5, copper 1.9. We have this example here. This is the perfect example. Aluminum is 1.5 millivolts of electronegativity, and this is 1.9. This is the element with higher energy, this is the cathode, and this is the element with less energy is the anode. The copper attacked the aluminum, like I explained before, corroded the area around the contact surface, and the aluminum is eroded and suddenly is perforated, and you have a leak of the fuel or leak of water, depending on the tank, if the tank is for fresh water or for fuel. Okay, my friend, important. For that reason, I am going to explain later, it's critical the connection of the shore power in your boat, especially the ground, because through the ground you drain those extra currents, and if the ground is properly installed, you have a good drain, and you don't have current circulating in between the metals. Let me explain what is the meaning of that. We are going to talk later about that. But right now it's clear that each metal have your own level of energy. Each metal have your own electronegativity. If I have two dissimilar metals together in contact one with the other one, the element with more electronegativity attack the element with less electronegativity. And at the end of the day, the less noble metal will be eroded. The name of that type of corrosion is galvanic corrosion. Galvanic corrosion is when you have two dissimilar metals in permanent contact. And a small arc of electricity is produced because you have two different levels of energy, and that small arc of electricity accelerates the corrosion from the more noble into the less noble. This is galvanic corrosion. Is the corrosion produced in the contact area when you have two dissimilar metals together in a marine environment. That's it. This is galvanic corrosion. Later we are going to study with more details the most common type of corrosion, galvanic corrosion. Two dissimilar metals together in a marine environment. This is galvanic corrosion. What happens if you have two dissimilar metals together, but additionally you pass a current in between both metals? You accelerate that corrosion. This is electrolytic corrosion. It's galvanic corrosion plus a small current in between both of them. That's it. What is the difference between electrolytic corrosion and galvanic corrosion? In electrolytic corrosion, you have two dissimilar metals together plus extra current. In galvanic corrosion, you only have two dissimilar metals together. That's it. Bingo? It's clear? For that reason, if you have current passing through the metals, it's a good idea if you drain that current through the ground. You remember in our courses of electricity? That cable that connects is the grounding cable, you remember? And that cable is connected to the bonding terminal, and the bonding terminal finishes into the sink. In other words, the sink in your boat, the sink in the transom of your boat, this is the ground of your boat. Because everything is connected to the bonding internally and finish into the sink. At the end of the day, the drain is on the sinks, and the sinks are in contact with the water and in contact with the ground. Finito. Okay? For that reason, the short power connection is critical, especially in the ground terminal. I am going to explain later what is the meaning of that. What is the meaning of the connection of that terminal. And okay, I explained the chemical bondings. I explained that there are ionic bonding when you have two different atoms creating the molecule. That connection is permanent, is ionic, like a salt, you remember. And for example, the oxide of metals, oxide of aluminum, oxide of copper, oxide of zinc, those are ionic bond, is permanent. And the other one is the covalent bond. The covalent bond, when you have two equal atoms together, for example O2, and when you have a dissimilar for example sodium and chlorine, this is ionic, and this is covalent.